Hello, welcome to Econometrics Melody. This is the fifth video on miscellaneous series in Stata. In miscellaneous series in Stata, we'll cover some of the basic, general, and handy topics in Stata. This will be more of a practical session. Let us begin. Let us clear the data in the memory, if any, and let us also clean the result or output window. Set our observations to 21. Data containers for 21 observations are ready, and we're going to use for values to create or generate 5 variables. For values will accept only the numerical ranges, and while for each loop is going to accept other varieties of lists as well, which will be clear as we progress in this too. Now let us, our 5 variables are generated from a1 to a5, so I is taking the value 1 first and executing this command, and 2 at the second, and so on all the way to 5. Now let us see our for each loop. For each loop is going to accept many other lists. Anylist is unnamed list, variable list, and then numerical list, local variable, global variable, and then new list. Yeah, these are the lists accepted by for each loop, and for each loop therefore has a broader scope than for values loop. For values loop is limited to only numerical lists or numerical ranges rather. Now let us see how does it work. We have just written down the elements of, so these elements comprises of a list, and we have not declared that list. So how does it work? For each x, or for each element in this unnamed list, we are going to execute this command so many number of times is the number of elements in this unnamed list. Our output result, and let us see, this is the summary, and this is the description of 5 variables. This is the regression output, where first variable a1 is considered as dependent variable, and a2 to a5 these variables are considered as independent variables, and these are the correlation coefficient results. And our second example of any list, so this is also any list because we have simply specified the elements and this comprises the list, but any unnamed list we have not declared the nature of this list, and again that is why we use this word called in. So the explanation goes this way: for each element in this unnamed list, execute this command for the values of each element in this unnamed list. Again, this is a summary table of these variables a1 to a5. Here we have specified written all the individuals from a1 to a5, but here we have condensed it, and we have simply specified a1 to a5. Again, this is going to, this is an unnamed list or any list. That is why we use this word in. So for each element in, so x or y, or this can be the reference for element can be any variable. Create a summary table, and this will again create a summary table. Now let us explicitly declare the nature of these elements of this list. It is going to be called as a variable list. Now as we have declared the nature of this list, we use the word called of. So for each element out of this variable list, we are going to summarize it. It is going to create a summary table. Now let's switch to numerical list. Again, let us practice it 1 to these numbers, and but its declaration we have not made any declaration over here. That is why we use the word called in, and let us again explain it. For each element in this unnamed or any list, we are going to execute or display x cube of these elements. So let us see the result. So the result up to 9 cube is fine, but here Stata took it as 13 divided by 21 and calculated its cube, but in fact we wanted to specify this as a number from 13 to 21. So this didn't happen because we have not declare the nature of the list. Now once we declare the nature of the list, this problem will be solved. So we are going to declare these elements. It constitutes a list, and we are going to declare the nature of that list. It is a number list. and each we have declared the nature of the list, we use this word called of. So for each element of the number list, we are going to calculate the xq value, and let us say this time we should get the result. So once again, a reminder, if we don't specify the name of the list, then we use this word called in. But if we declare the nature of the list, then we use of followed by the declaration of the nature of that list. It is that simple. Now let us try another way of executing the for each loop. We are going to create a local variable x. Actually local, it's a variable, or local and global, these are the macros, or local variable or global variable. Here local x, we have declared x is a local variable that stores the values from 1 to 5, and while executing our for each loop also, we are declaring the nature of this x. X is storing the values from a1 to a5. So we have now this x is a list, so we have declared the nature of that list. That is why we use the word called of, and here m is representing the element. So for each element of this nature, that is a local variable, this list x, we are again going to create a summary table, and this is again going to create a summary table. This is very simple. Now rather than explicitly declaring the list, nature of the list, we are simply calling the local variable. So if we need to call the local variable, we use this sign. If we need to call the global variable, we use the dollar sign. Again, same process. We first of all declare the variable x as a local variable and store the values a1 to a5 in it. Then after, rather than specifying the nature of this, x contains the values from a1 to a5, but in for each loop we have not declared it explicitly. That is why we use the word called in. So again, the summary table of a1 to a5. Same is the case with global declaration or global variable. So we are declaring x is our global variable that stores the value a1 to a5, and then in our for each loop also we are declaring the nature of the list. Here x is the list of a1 to a5, which is clear by this syntax, and we are again declaring it is a global variable. So as we have declared the nature of this list, we are going to use the word called of, and em represents any arbitrary value. We can write it here. Let's write ARAR for each r, and we can also write here ARAR. This should list the variables a1 to a5. This is it. Now as we have already declared the global variable, so global by its name, we need not again declare it for calling it. So we didn't. This is the nature of the global variable. Once we declare it, we can call it any number of times within the same working space. Now for each element in, this represents calling of the global variable. But in the for each loop, again, we have not explicitly declared it, though it is we are calling a global variable, but we have not declared it in the for each loop. That is why we use the word called in over here. Here, the previous case, we have explicitly declared it as a global variable in the for each loop itself. That is why we use the word called of. And here, though it is a global variable, we have not declared it in the for each loop itself. That is why we are simply treating it as an unnamed list, and we use the word called in. And again, this is going to create a list of m. So if we run it, get a list of m means a1 to a5. We are listing it. Now let us use, or let us see some of the examples of new list, or the example of new list. For that, let us clear everything that we have in our memory, actually the data set in the memory. Clear it. Let us also clear the output or result window, set our observations to 21. Now we don't have any variables, so we are asking that, we are referring that b1 to b31 is a new list. We have declared it, the nature of this list. That is why we use the word called of. For each element of this new list, please generate x. X here means b1 to b31. We are going to generate 31 variables, and if we summarize it, this would be b1 to 31, b1 to b31. Let us see a short example, a nested loop. Let us clear the data from the memory. Then after, let us clear the output of or the result window as well. Set our observations to 21, and then we are again declaring x is a global variable, and it contains the list of ABCD. ABCD are the elements of that list. For each element in $x, it means ABCD. We are going to generate M, means we are going to generate a variable ABCD, and we draw random numbers from uniform distribution, and we generate 4 variables. We have generated ABCD. Now what are we going to do? We are actually running for each loop 2 times. It's a nested loop under a loop. So once for this ABCD, when we say $x, we should see it implies ABCD, so it is a global variable. No need to declare it once again. We can call it. So for P means for each element in $x means again ABCD. We want to execute this command, and again we are referring to for each Q in again ABCD. We are going to run this command. So actually we are creating a Cartesian product of ABCD is the name of the variables, and we are generating it by using this row. First of all, the value of P is A, and the value of Q runs from A to D. Second, the value of P is B, and the value of Q runs from A to D, and so on. So let us execute this and see it for ourselves, and let us summarize it, and we want to see the Cartesian product of ABCD. These are the variables that we have created by using this nested loop. First of all, the value of P is A, then after the value of Q is ABCD. Second, the value of B is B, then after the value of Q is again ABCD. This is the Cartesian product, and we have to type this. So we can make use of for each loop to solve our problem according to the nature of the problem. So again, for values loop, it accepts only the numerical ranges, while for each loop it accepts any list or numerical list, variable list, varlist, numlist, after global variable, local variable, as well as new list. So this is it for this tutorial. Thank you very much for your time. Thank you very much, Econometrics Melody.